Okay, this is the beginning of a new series of recordings, and these recordings are going to be looking at the demos that I have on my Moving AI demo webpage. The first video we're going to look at today, or the first demo, is going to be looking at depth first search, breadth first search, and depth first iterative deepening on an exponential tree. So the point of this demo here is to get a better understanding of exponential trees, because we can talk about, well, the tree grows as b to the d, but what exactly does that mean in practice? And so this is why we're actually going to run these trees down at the bottom here to be, have very many nodes. And so here, the first thing we can do is we can choose one of these buttons to choose the branching factor. So branching factor of 2. And the depth of the tree actually is influenced by the branching factor. So at branching factor 2, we see 1, 2, 3, 4, 5, 6, 7, 8, I believe depth 9 here. And so about 512 nodes at the top, and therefore about 1,024 nodes or 1,023 nodes total. If we go to a branching factor of 9, then we actually only see depth 1, 2, 3, but there's actually more nodes in this tree, or looks to be more nodes than they are in the tree of branching factor 2. And so you can look at each of these, and the trees are sized appropriately. And so this just helps us understand when we have an exponential domain, what is going on in an exponential domain, like how do our algorithms perform? And some of that is covered in the lecture, but maybe seeing this is going to give us a better sense of actually visually seeing and understanding things. So in this particular demo, what we can do is we can choose a different algorithm to run, and we can toggle because we can also run them at the same time. So I'm going to turn just breadth first search on to get started, and we'll start with a branching factor 2 tree. And then I can basically run and pause this algorithm. So in this case being breadth first search. So if I run my breadth first search, what we're going to see here is the purple states are the nodes that are on the open list. And we can see, so the last one is being expanded, it generates its children. And we're going to see it's going to go through this entire tree. And it goes through from top to bottom. Eventually it'll reach the last node here. And we can see there's actually a lot of purple states, especially when we started this last layer. As a reminder, we have to keep all of those in memory at once in order to run a breadth first search. And that memory requirement is one of the reasons why we don't always use a breadth first search in practice. So we can turn off the breadth first search. We could look at the alternate, which is a depth first search. And so this search is going up and down the tree and is going to make its way across. So one of the things we might do for this demo, we'll look at a number of different things. Right now, this little cyan circle down here is the goal. And what we're going to do right now is we're going to keep the goal in the bottom right-hand corner, but I can click and I can move the goal to be somewhere else. And so that'll be something we'll think about later. So I can see my depth first search. We see the depth first search is actually only keeping this one branch in the tree, so we can see it uses a lot less memory than maybe keeping all the nodes at one time. But we do see that it goes up and down the tree. So we could ask the question, for instance, if we compare a depth first search versus a breadth first search, what do we expect to see the difference in the running time? And so we obviously, might want to stop the video and you could try to do a calculation. Here, when we're doing the depth first search, we have to go down our first branch, and then we go up, and then we go down our second branch, and obviously recursively we'd go down and up and down and up and down and up. And the way that I visualize this, of course, matters in terms of what we see as performance. So here we're going to animate going down and going up. With the breadth first search, we're just going to expand, 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 expand. And so there what we can see is that there is one operation of expand versus going down and versus going up. And that is why a breadth first search in terms of operations that we're mapping to time in this demo, we're going to see a breadth first search running faster. So we'll turn a breadth first search on. So we're going to run depth first search and breadth first search, and we can run them and we can watch. So here's the breadth first search that's going. There's the depth first search. So the breadth first search is now doing the second to last layer, coming across here. That's where everything's in memory on the bottom layer. and now we're coming across. And what we see here is that when this comes to the end right here, then our depth first search is halfway through the tree. So if we think about the depth first search having to go up and down each branch, where the breadth first search is sort of expanding, then we'd expect our, in this demo, in this animation demo, for the depth first search to take twice as long. Now, exactly what's happening there, like we're making copies of states versus making incremental modifications of applying and undoing moves. In practice, the running time could be quite different in a real application, but that's how we're demoing things in this demo. And of course, your performance in a real world domain could vary quite a bit based on the actual cost of, in a particular domain, of applying and undoing a move versus just expanding. Okay, so then what we can do here is we can turn off our breadth first search. Let's pause that. And we can turn on our depth first iterative deepening. And actually, before I do that, let's go back and the question we could ask is, well, what if I use a higher branching factor? So I'm going to use a branching factor of 4. And we could ask, how is the running time going to change between a breadth first search and a depth first search? Will that ratio stay the same in speed, or will it change as we increase the size of the tree? So we could run this here and watch with branching factor of 4. And if the ratio stays the same, we expect the depth first search to get over to here, about halfway through the tree, about the same time that the breadth first search gets through the tree. And sure enough, we see that. So that ratio stays at about a factor of 2. We could go up to a branching factor of 6. We'd try to verify the same thing. Again, we'd expect it to get halfway across. And since this is the case, as we see here, that this is sort of a fixed constant factor of 2, what that says is that the differences, are going to be these constant implementation differences. It doesn't matter what the branching factor is, and we won't always see that. Okay, so turn off the breadth first search. Let's look at depth first iterative deepening. Actually, so let's just watch our depth first search first, right? So it's running across the tree, and it goes from top to bottom, left to right. If I do a depth first iterative deepening, what we see is it does the first level, it does the second level, and then it does the third level. Okay, so if we go back to a branching factor 2, we can now compare, and we can ask, if we're running depth first search and depth first iterative deepening, what is going to be the difference in the running time in a tree with a branching factor of 2? Okay, so that's something to think about, trying to answer that question. And I'm going to keep talking, but feel free to pause the video and answer these sorts of questions. And we can run it now and we can watch what is the difference. So what we see is that the red line is the depth first iterative deepening, which is running across. And then we see the blue line is the depth first search going across. And we can just watch these for a minute and see what happens, at least until the red line gets to the bottom. Okay, one more layer in here that has to go across. Notice that it started that layer about when the blue line got halfway across. And the red line's catching up here. So here we go. The depth first iterative deepening is going to finish the second to last layer right around the time that the depth first search finishes. And what you see here then is that the depth first search is finished. The depth first iterative deepening is now sort of starting exactly what the depth first search did, exactly when the depth first search finished. So what that tells you is going to be twice as long. Okay, so we saw with a breadth first search and a depth first search that there's a factor of 2 difference, and it didn't matter based on the branching factor. So now we can look here and we can say, well, what happens if I change the branching factor? Will I still see this factor of 2 difference between depth first iterative deepening and between depth first search? So let's pause this. Let's go ahead and we'll make the difference as big as possible. So we'll go to a branching factor of 9. And so again, pause the video. You can think about this. What is the difference going to be in the speed? Is it going to stay a factor of 2, or will it become less? Okay. And I'm not going to answer all these questions here. We can watch it and see it from the demo, but the video, the instructional video below gives you the theory or gives you some of the math behind this. But what we can see is actually here, the red depth first iterative deepening has actually already started the bottom layer. It's just slightly behind the blue line, sort of one of these branches behind. And so you can do the math to work it out exactly, but what's going on here is that as the branching factor gets larger, the depth first iterative deepening is getting closer and closer to just being the same as the depth first search. And that's essentially because the number of nodes in these higher layers is fewer and fewer relative to the nodes in the entire tree. Most of the nodes are at this bottom layer. And so so we actually do the overhead of iterative deepening gets smaller and smaller as we have a higher branching factor. And at branching factor 2, it's only a factor of 2. Here it's going to be even less than that. Okay, so we've been just looking at these algorithms here in a basic way, and now what we can do is we can start to look at them by looking at what happens when we change where the goal is. So I'm going to pause this, and now I'm going to think about where can I put the goal. And so this is an interesting thing to think about, is where can I put the goal that will maximize the difference between the performance of depth first search and depth first iterative deepening, or the other way around. So first we could ask, well, what's the best possible thing we could do for depth first search? I'll let you think about that, the best for depth first search, and you can pause and think about that if you want to, and then I'm going to go put the goal. So I'm going to click. So just to show you here, I can click, it'll put the goal wherever I want you to. So you could choose somewhere, you could run it, and you could see what happens there. And in this case, I'm going to put the goal all the way in the farthest left corner there. And when I run it, what you see is the depth first search is done. It's already found the goal. And the depth first iterative deepening takes a while, and now it's going to come here. Now note that if we had multiple goals or other things like this, that the depth first iterative deepening would find multiple goals and find the right one. Depth first search may not be optimal or complete, depending, again, whether your graph is infinite or not, and some other details like this. So depth first search isn't, in this one case, it's going to do well, but maybe not going to be the best algorithm all the time. And we could illustrate that by choosing a different goal. So where's a goal we could put in that's really going to illustrate the difference between depth first iterative deepening and depth first search? Again, you might want to pause and think about that, or try it yourself, and then we're going to go here. If I put the goal here, the depth first iterative deepening comes right across and finds the goal. The depth first search is searching deeper than the goal. So it's actually going to do, in some sense, an exponential amount of work, depending on, of course, how deep the problem is. But it's going to come all the way across here. It has to do a massive amount of extra work before it gets to the goal here. So we're going to see very, very poor performance from depth first search here. If we turn on breadth first search, we run all of them, we're going to see, in this example, the depth first search finishes quickly, or the iterative deepening finishes quickly, the breadth first search finishes quickly, but the depth first search does not. And so, of course, the breadth first search has to keep all these purplish pink states in memory, but both those algorithms find the goal quickly here, where we're not going to wait for the depth first search to finish. And the other thing I can do is we just go back to a branching factor of 2, and then we can put the goal up here. And now we can see, for instance, the breadth first search and the depth first iterative deepening found the goal very quickly. And now we're actually going much, much deeper than where the goal actually is. The branching factor is smaller, so the number of nodes is actually not much, much more. But we just see the difference in performance between depth first search, depth first iterative deepening, and breadth first search. Okay, so in general, we can look here. We can just get a chance to see all these different trees, see the performance on all these different trees. We can compare any set of algorithms here by toggling them on and off, which is showing which ones are running. We can choose a goal in here. And for instance, we could ask, well, is there a location that we could put the goal that would favor depth first iterative deepening over breadth first search? So there's an interesting question. Is that possible? Or is the breadth first search always going to finish first? And Yeah, and so this is what the demo is showing here. We could also be sort of looking at how many nodes there are to get a sense of this exponential growth with b to the d nodes at the bottom of the tree, and how that is so many more than, at the top here we've got 4. Um, yeah, this is a branching factor 4. You could think about how many nodes are here at the bottom of the tree, and even could try and count and verify those if you wanted to. So this is the first lecture in this series that is, or first demo in this series that's going to go through these demos, and we'll try to release these whenever we have the chance to go through some of these demos. Also maybe clean up some of the visualizations as I do this, and hopefully they're helpful in not only just being able to play with them, understand them. If you're an instructor, you can look at the types of questions you could ask your students to be thinking about as you maybe give them these demos and allow them to play with them. And the code for all these demos can be downloaded and compiled. If you don't want to actually deploy it on the web page, they can be deployed elsewhere. That is not something that's easy to do right now, but we're working on putting together a better repository for that. So thank you for watching, and we will see you next time.